Hi everyone, it's been a while. I've settled into my new school, Anglo-Chinese Junior College. One of my subjects is H2 Further Mathematics. One of my first topics for that is polar curves. So, I thought I'd like to share this question I saw from my tutorial. Show that the distance between 2 points whose polar coordinates are r1 and θ1 and r2 and θ2 is the square root of r1 squared plus r2 squared minus 2r1 r2 cosine θ1 minus θ2. So how can we start? We know the Cartesian form of the length formula, and we know how to convert Cartesian to polar coordinates. So let me just write that out for you. Should be somewhere in your lecture notes. Ri squared is equal to xi squared plus yi squared, right? We can also express sine theta and cosine theta in terms of this. We have sine theta I equals to yi over ri, and we have cosine theta I is equal to xi over ri. Once again, the derivations of all these should be somewhere in your lecture notes if you take further math. Alright, so we're going to start with the Cartesian form of the length formula, which I think is quite familiar to everyone because we have done O-level E-maths. That's why we learned it. So we have the square root of x1 minus x2 squared plus y1 minus y2 squared, right? I'm going to expand the whole thing. That is x1 squared minus 2x1 x2 plus x2 squared x2 squared. Then we have to plus y1 squared minus 2y1 y2 plus y2 squared. Okay, now I'm going to group some stuff up. I'm going to underline these two in red. I'm going to underline these two in blue, and the other ones will be in green. Now, the reason for that is you'll see why. The red and blue, you can see that actually this will give us our ri squared. So let me write that first. We have r1 squared plus r2 squared. And then the green ones, we can factor out the common minus 2. Minus 2 of x1, x2 plus y1, y2. Right? So what's next? We have the r1 and the r2 squared each, and that is the first part here, which is nice. But how do we get to this cosine thing? Well, maybe it would be nice if I can express this into the form of the sine theta I and cosine theta I. So let me write this out. This is still the square root of r1 squared plus r2 squared. Now I'm going to multiply and divide by r1 and r2. So this is still x1, x2 plus y1, y2, and the whole thing divided by r1, r2. And I'm sure you can see that this and that would have cancelled and is equivalent to what we have at the top. Alright, let me come over here now. Now I'm going to rewrite whatever is in the brackets. So first, let me rewrite the whole thing. r1 squared plus r2 squared minus 2r1 r2. Now I can rewrite what is in the bracket as x1 over r1 times x2 over r2 plus y1 over r1 times y2 over r2. And if you work it out, this is exactly the same as what we have earlier. Okay, and you might start to notice something. This can be changed to this, and similarly for the y over r. So let me just do this. r1 squared plus r2 squared minus 2r1 r2. Alright, let me convert each of these terms into the forms that we have. We have cosine theta 1, cosine theta 2, minus sine theta 1 and sine theta 2. Or rather plus, sorry, this should be plus. Okay, and you can recall, let me just underline this in red. You can recall from your O-level A Maths, the addition formula, that cosine A plus minus B, assuming that A and B are real angles, this is identical to cosine A cosine B minus plus sine A sine B. But if you really don't remember, don't fret, because this formula is also available in the MF26, which is your formula sheet for math in JC. Alright, so as you can see by the observation of this and apply it to the above formula, you can actually see that our A is theta 1 and our B is theta 2. And in this case, we have the plus here. Therefore, this should be the case of minus. So finally, you can see the end in sight, right? We have r1 squared plus r2 squared minus 2r1 r2, and then we have cosine, and then you can see by observation, theta 1 minus theta 2. And that is what was wanted, as you can see at the top here, right? That's what we wanted. So I'm going to put down shown. Alright, so this is a very good exercise just for you to see a little bit of your algebra skills, as well as a little bit of understanding about how we actually get r and sine theta and cosine theta in terms of x and y, converting Cartesian to polar. So yeah, hopefully you all enjoyed this. I hope to make more videos about H2 math and further math coming up.